In previous lecture, I discussed pigeonhole principles with example. Next, I will discuss Euler's totient function. What is Euler's function? It finds the number of integers which are co-prime to that integer. So, it counts the positive integers up to a given integer n that are relatively prime to n, and it can be represented as phi of n. Both symbol are fine and also called as Euler's phi function. So it will find how many integers are less than that number which are co-prime to that number. In simple word, you can say it is the number of integer k in the range 1 less than equals to k less than equals to n, for which the GCD of nk equals to 1. Okay, there are no common divisor, that's why GCD of n and k equals to 1. What is co-prime of 6? Less than 6, 1, 2, 3, 4, 5. Now 1 and 6 GCD is 1, 2 and 6 GCD is 2, 3 and 6 GCD is 3, 4 and 6 GCD is 2, 5 and 6 GCD equals to 1. So only 1 and 5 which are co-prime to 6. That's why phi of 6 equals to 2. Next, co-prime of 7. 7 is a prime number. So less than 7, 1, 2, 3, 4, 5, 6. All are relatively prime to 7. So GCD will be 1 in each cases. That's why phi of 7 equals to 6. So when n equals to prime number, phi of n equals to n minus 1. Phi of 3 equals to 2. Phi of 5 equals to 4. Phi of 11 equals to 10. So if n equals to prime number, then phi of n equals to n minus 1. All integers less than that numbers are relatively prime to that number. If n is not a prime number, then phi of n equals to n multiplication p1 minus 1 multiplication p2 minus 1 till pk minus 1 divide p1 multiplication p2 p3 till pk. What is p1 to pk? So n equals to multiplication of p1 p2 p3 till pk. So this is the formula for finding phi of n. How many integers are relatively prime to that integer n? Let's see one example that you can understand. Example 10, number of positive integers which are co-prime to 1, 1, 0. 1, 1, 0. So it will divisible by 2, 5, 5, then 5, 11. So 1, 1, 0, it is multiplication of 2, 5, 11, right? Phi of 1, 1, 0 equals to 1, 1, 0. First n multiplication 2 minus 1 is 1, multiplication 5 minus 1 is 4, multiplication 11 minus 1 is 10, divide 2 multiplication 5 multiplication 11. So this thing will be cancelled. 4 multiplied 10, it will be 40. So there are 40 integers which are relatively prime to 110. Phi of 110 equals to 40. Next, example 11, number of positive integers which are co-prime to 180. 2 divide 9, 0, 2 divide 45, next 3, 15, 3, 5. So 180 that equals to 2 square multiplication 3 square multiplication 5. Phi of 180 will be 180 multiplication 2 minus 1 multiplication 3 minus 1 multiplication 5 minus 1 divide 2 multiplication 3 multiplication 5. Now 2 minus 1 is 1, 3 minus 1 is 2, 5 minus 1 is 4, 2, 3, 5 that cancel with 180. So 1, 2 cancel, 1, 3 cancel, 1, 5 cancel. It will be 2 multiplied 3. Okay. 2 multiplied 3, 6. 6 multiplied 2, 12. 12 multiplied 4, it's 48. So there are 48 integers which are co-prime to 180. Let's see another example. Example 12, number of positive integers which are co-prime to 323. 323 is not a prime number. 323 equals to 17 multiplication 19, 323 multiplication 16 multiplication 18 divide 17 multiplication 19. So this thing will be cancelled. 16 multiplication 18, it's 288. So phi of 323 equals to 288. There are 288 integers which are co-prime to 323. Next, example 13. If n equals to p square multiplication q, where p and q are prime number of integer m such that 1 less than equals to m less than equals to n, and GCD of m and n equals to 1 is dash. Phi of n will be, or how many integers are there such that GCD of m n equals to 1. So phi of n equals to n multiplication p minus 1 q minus 1 divide p multiplication q. And what is n? N equals to p square multiplication q multiplication p minus 1 q minus 1 divide p multiplication q. So this pq will be cancelled. Here p square, here is 1p will be cancelled, 1p will be there. So it will be p multiplied p minus 1 multiplication q minus 1. So this is all about number of integers which are relatively prime, or you can say co-prime to n. Next, number of divisor or factor of n equals to a plus 1 multiplication b plus 1 multiplication c plus 1 multiplication d plus 1, like this continue. So what are these a, b, c, d? These are the power. Okay, so if n you can write as p power a, q power b, r power c, s power d. The number of divisor equals to a plus 1 multiplied b plus 1 multiplied c plus 1 multiplied d plus 1, like this it will continue, where p, q, r, s are the prime numbers and a, b, c, d, all these are the positive numbers. Let's see one example. Example 14. Number of divisor of 4200. Now 4200, if we'll divide by 2 multiplication 2, it's 4, 2 multiplied 1, 2, 2 multiplied 0, 2 multiplied 0. Again divide by 2, 1, so it will be 2, 2 multiplied 0, 1, 2 multiplied 5, 10, 2 multiplied 0. Again divide by 2, 2, 5, 10, 2, 2, 4, 5 minus 4, 1, 10, 2, 5, 10. Now divide by 5, 5, 1, 5, 0, 5 multiplied 5, 25. Now divide by 3, 3 multiplied 3, 9, 10 minus 9, 1, 15, 3, 5, then 5, 7. Okay, we got 2 power 3 multiplication 5 square multiplication 7. Now number of divisor will be 3 plus 1 multiplication 1 plus 1 multiplication 2 plus 1 multiplied 1 plus 1. 4 multiplied 2 multiplied 3 multiplied 2. 4 multiplied 2, it's 8. 8 multiplied 3, 24. 24 multiplied 2, it's 48. There are total 48 divisors of 4200. Let's see next example. Example 15. Number of divisors of 2024. 2 multiplied 1, 0, 1, 2. Again divide by 2, 5, 0, 6. Again divide by 2, 4. So 10, 2, 5, 10. 3. Now 2, 5, 3 we can divide by 11, 2. It will be 22, then 33. So 11, 3. 2 power 3 multiplication 11 power 1 multiplication 23 power 1. 23 is a prime number, so there are no divisor. Now number of divisor of 2024 equals to 3 plus 1 4 multiplication 1 plus 1 2 multiplication 1 plus 1 2. It's 16. So there are 16 divisors of 2024. In today's lecture I discussed Euler phi function, where we can find number of integers which are co-prime to that integer, also divisor or factor of n. In next lecture I will discuss D arrangement. If this lecture is helpful for you, please like, share and subscribe. Thank you.